Hello guys, and here it is Genius File Studio presenting a new video to you. Light and radiation. Light and radiation is everything you can see in the universe, whatever you can sense. So it's one of the founding parents of our universe. So light and radiation gives us a sense of the universe. It gives us what we see in the universe. It gives what we feel in the universe. Without light and radiation, there'd be whatever we see around us, whatever almost everything we sense around us, it wouldn't exist. So today we'll be talking about light and radiation. So light and radiation is um, what we can see here. Many objects, everything in space, every single thing in space, both takes in light, absorbs light, and releases light. So it absorbs light. Absorbing light is for itself, or like absorbing the energy from the photons, and that's how it gets its energy. And releasing the light is what we see, whatever we sense. So I'll be talking to you deeper about this part right here. But before we talk about that, we need to talk mainly about light and what it is. So this is the electromagnetic spectrum. The electromagnetic spectrum is a graph, a diagram scientists have made to help us understand what light is, to help us understand what light does, to understand how light helps humans. So light is separated into three main categories. So the first category is infrared. So infrared. The second category is visible light. Visible light is what you can tell by the vocabulary is what we can see, the light we can see. And ultraviolet, and the final one is ultraviolet. So by the words, you can tell that infrared is infrared. Visible light is just visible light you can see, and ultraviolet is violet. So mainly color wise. So let's separate this spectrum into those three categories. So this category right here is infrared. This category right here is ultraviolet radiation, and this category right here is the smallest portion, but it's the most important part to human sense, visible light. And here's a more zoomed in drawing for that right here. So first we're going to be talking about infrared. We're going to be focusing on infrared. Infrared is mostly used by humans. It's what helps humans communicate. Our phones, our radios, all of that uses radio waves. Radio waves is how radios work and how our phones communicate from one part of the world to the other part of the world. So radio waves helps us learn, like helps us it's the longest wave. It has the least frequency. So as you can see here, its wavelength is really long before reaching here. So this, I'm going to explain what frequency means. So the frequency is how many times something occurs, or how frequently it comes. So in light, frequency works like this. So let's say we have these two waves here. The frequency is the length from this wave to this wave over here. This is the frequency right there. So the frequency here is less because the longer the wavelength, the lower the energy, or the lower the frequency. So longer the wavelength, the lower the frequency, the shorter the wavelength, the more frequency. Because more energy it has, the more times it can go up. Less energy, it's unable to go up that much. It takes a while for the energy to build up to go up. So radio waves has the least amount of frequency. It's less frequent for the top wave to top wave for both waves to come at the right altitude. So radio waves are usually 30 millimeters long, and radio waves are used in our phones for communicating, for broadcasting, for radios, and so much more technology we use in our daily life. Then we have microwaves. Microwaves is slightly more frequent, has a slightly more bigger frequency, and it is also used by scientists a lot. Microwaves are used for is a different type of telescope. So microwaves are used by scientists to learn more about our universe. It absorbs the microwaves. Microwaves are like the light released by our like light released by other objects really far away in our universe. So like if you were to look at the Milky Way, the white light which we can see in the Milky Way in the sky, that is microwaves. So that's how scientists study um, stuff, objects, celestial objects in the universe. Microwaves are also used for heating food. So microwaves are usually used for tracking how much kinetic energy or what's the temperature of each atom. So that's what microwaves are and what they're used for by humans. And finally, in the this is the infrared category. Infrared category is red. It's not visibly red, but if you were to if you could make infrared light into visible light, it would be red. So this is kind of like a tuning. So it starts off like a really low frequency and then it increases frequency till here it's the most frequency. So that's why if you look here in visible light, it starts off red here and then it turns violet at the end. So that's how it works. Visible light is what we can see. And you should remember the formatting of this because this will be really important later on when we'll be talking about the plants, green plants. So please remember this visible light part, like the color. So it starts off as red, tunes into orange, and tunes into yellow, then tunes into green, aqua, blue, and then finally violet. And then now we're going to be going to the third category, which is ultraviolet. Ultraviolet has the highest amount of frequency and is harnessed by harnessed by humans, but is really, really, really harsh to humans if you don't use it right. So we use mm, ultraviolet radiation for looking at stuff. So ultraviolet radiation helps to look deeper into our universe. So our sun releases ultraviolet radiation or UV. You can say UV. So that's just really harsh to the human body, as well also helps it. So X-rays. X-rays are used to um, X-rays are used to like it goes through all your flesh, your skin, and it looks at your bones. So that's how X-rays work. And X-rays are also used to look at other celestial objects in the universe. And finally, you have gamma ray. Gamma ray has the highest frequency. It's super high, at 0.01 nanometers. And gamma rays are used for some medical help, but is mainly gamma rays is if you have heard of gamma ray stars, gamma ray stars are like stars like wait, let me show you what gamma ray stars. I had a picture of it here. This is a gamma ray star here, right here. This is a gamma ray. Like as the orange star has all these gravitational pull, this purple radiation releasing from all sides. So this is what a gamma ray star looks like. And gamma ray is so harsh that if one of the beams from one side would have contact with the sun would blow up, like literally blow up. So gamma rays are like one of the most harshest radiation, most toxic, and That is our electromagnetic spectrum. And now let me talk about what I was talking to you before about plants. We all know what plants are. Are some living organisms that grow everywhere around our planet. And there's no place where they do not grow. And here's a question which we all also know. Why are plants green? Plants are green because of chloroply. And that is true, but that's not what we are focusing on right now. That's not what we're focusing on right now. We're focusing on right now, we're not talking about biology right now. We're, we're talking about our, our astrophysics. This is what's called astrophysics. Light and radiation. You can call it physics or you can call it astrophysics. But because I'm doing astronomy videos right now, this is astrophysics. So, why are plants green? Chloroply. But what do chloroply do that makes our plants green? Well, that's a totally different question over here. And now we'll remember I told you to remember the colors of the visible light. Well, here it is again. So we have red, orange, then yellow, then green, then blue, and then violet. This is how it looked like. And then over here, the radiation, why are plants green? So our plants make food, live by our sun. So helps plants our sun helps plants get light, and it helps plants live. And what light does our sun what is our sun? It is a yellow dwarf. Yellow dwarf. So remember yellow. So because it's a yellow dwarf, it releases yellow light, mostly yellow visible light. Yellow. So this is how our plant survives. And also remember the part when I told you that everything both absorbs light and also releases light, visible light. So that's why everything has a color. So plants absorb yellow light because that's how they photosynthesis and that's how they live. But how is it green? That's the actual question. So now let's talk about that. Our sun mainly releases yellow, but that doesn't mean that it only releases yellow light. It also releases other colors. So in this case, it would look something like this. Wait, that's not a good drawing. It looks something like this right there, like that. This is how much. It's not the exact amount of light the sun releases, but just think of it as something like this. That yellow is the peak. So the plants take in yellow light because that's the light which is mostly released by the sun. That's the only way they can live. We can take out yellow, the yellow category right here. So we can erase this because this is what the plant takes. And so this yellow light is what the plant absorbs. But then what does it release? So now if we were to draw this again, this diagram again, it would look something like this. So red, orange, yellow, green, red, green and blue, excuse me, violet. So it would look something like this. So this is how much light mostly the light the chloroply releases. So because green is the peak and the majority of the visible light it has, this green light, um, if you were to use math in this case, would it would cross out it's because it's so big, it would cross out all of this light, leaving only green light. So that's why our plant releases green light. And because it releases green light, and when that green light comes to our when it comes to our eyes, like that, we sense green light. We are able to sense green light. And because we are able to sense green light, that's why we know that plants are green. So that's why plants are green. And this is how our universe uses all the different types of light and radiation to prosper, to live, and to be in the universe. And that's how, without light and radiation, we won't be able to see anything, we won't be able to sense anything, and nothing would be here. So that's why light and radiation are the founders of our universe. Thank you for watching, and please subscribe and like this video. Thank you.